Welcome to today's lesson. Today we are going to learn how to prove trigonometric identities. An identity is an equation that is true for all allowable values of the variables involved. We looked at this identity previously and we said that the tan of theta is identical to sine theta over cosine theta, and note this identity has got the left hand side, which is the left hand side of the identity sign, and it has a right hand side. So we've got the right hand side of the identity side. So in this particular case, the left hand side is tan theta and the right hand side is sine over cosine theta. Okay, so if we have got this identity, what we want to show is that for all allowable values of the variable theta, the left hand side is going to be identical to the right hand side. So we've got we're going to take various variables, the first variable being 0 degrees, second variable 30 degrees, and the third variable 45 degrees. And so what we're going to be doing is we'll take tan theta, so tan 0, solve what tan 0 is equal to, and then solve sine 0 divided by sine 0, and show that if theta is equal to 0, this side is going to have the same value as that side. And then we'll continue to do the same. We'll do it for 30 degrees and we'll do it for 40 degrees, because we want to show that this identity is true for all allowable values of the variables involved. Okay, so if theta is equal to 0, we'll be doing this on a calculator, and make sure that your calculator is changed to degrees. Okay, so 0 degrees, then we'll press on tan. The answer is giving us 0. So the tan of theta is equal to 0. And the sine of theta, which means the sine of 0, so we press on sine, it also gives us 0. And what about the cosine? The cosine of 0 is 1, so we're going to have 0 divided by 1, which is equal to 0. Now notice that the tan of theta has exactly the same value as sine 0 over cosine 0, which is equal to what? 0. Okay, so let's try this for 30 degrees. So 30 degrees of the tan is 0.5773, which when abbreviated can be written as 0.774. What about 30 degrees of sine? 30 degrees of sine 30 degrees is 0.5. Okay, so we've got 0.5 here on the denominator. What about 30 degrees of a cosine? 30 degrees of a cosine is 0.866. So if we divide 0.5 divided by 0.866, our answer is 0.5774. Okay, so again we are saying that if the variable here which is involved is 30 degrees, the tan of theta is going to be identical to sine 30 degrees divided by cosine 30 degrees. They'll have exactly the same value, which is 0.5774. Okay, now let's try the last one, 45 degrees. So 45 degrees of tan is 1. 45 degrees of tan is 1. Tan 45 degrees is 1. What about 45 degrees of sine? Sine 45 degrees is equal to 0.7071. Okay, 0.7701. And the cosine of 45 degrees, cos 45 degrees, is also 0.7071, which when we divide is simply going to give us 1. So we're saying that if tan is 45 degrees and sine here 45 degrees divided by 45 degrees, this identity is going to be it's going to be identical. The right hand side and the left hand side will be the same. Okay, so this is what identities stand for. Now let's try to prove an identity. To prove that an equation is an identity, we need to apply known identities to show that one side of the equation can be transformed into another. Example. Okay, so here's an example. We've got cosec theta multiplied by tan theta, and we are saying that it's identical to sec theta. Okay, so what we're going to do is we're going to take the complex side. That's the first tip. When you're proving an identity, always start with the more complex side. And in this particular case, the complex side is cos theta multiplied by tan theta. So our left hand side is a complex side, and what we're going to do next is we're going to express everything in terms of sines and cosines. So we're going to say what is cosec theta in terms of sine or cosines, and what is tan theta in terms of sines and cosines. Okay, so we know that cosec is the reciprocal of sine. Okay, so cosec simply means 1 over sine, and we know that tan theta is identical to sine theta over cosine theta. Okay, so what we'll do next is we'll combine the terms into a single fraction. In other words, we're going to cancel out what's common on the numerator and the denominator. So here what's common is sine theta. So sine theta and sine theta will cancel out, leaving us with simply 1 over cosine theta. And 1 over cosine theta is an identity it's a reciprocal for sec theta. Okay, so we started off with the left hand side, which is cosec theta being multiplied by tan theta, and we have simplified it to cosec theta, which is the right hand side. So which means that we have proved that the left hand side is identical to the right hand side. That is all that we'll be doing in the next few lessons in proving an identities. Thank you.